Hi, this is Mark Sarazano from the International Piano Technicians School, and this video is on how to use check notes to test an interval size. Consider A3. The harmonic series tells us that there are multiple frequencies being produced at the same time as A3. This includes the fundamental A3, the second partial A4, the third partial E5, the fourth partial A5. Now let's consider another note, A4, an octave above A3. What partials are being produced when we play this note? Well, the A4 is being produced, but also the second partial, A5. These two partials are coincident. A5 is the coincident partial of A3, A4. And if we can tune this octave so that each octave's coincident partial is the same frequency, there will be no beating at that 4-2 coincident partial, and we can say that this is a pure 4-2. But how can we tune a pure 4-2? Just listen to the 4-2? There's a better way. We use a check note. The 4-2 check note for A3, A4 is F3. Let's look at the partials of F3. We have the fundamental F3, then the second partial F4, third partial C5, fourth partial F5, fifth partial A5. It's the same coincident partial as the 4-2 octave of A3, A4. It's a fact that the F3 is tuned slightly flat of the A3, A4, 4-2, and we can use this to measure the 4-2 coincident partials of A3, A4. Simply play the check note with each interval note and compare the beat speeds. When you play F3 with A3, it will be beating, and the speed of the beat will tell you how sharp the fourth partial of A3 is compared to the fifth partial of F3. Now just compare that speed with the A4. If they are the same speed, the coincident partials are the same frequency. But what if they aren't? Let's say we play F3, A3 and we hear a beating, la 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 la. Then we play F3, A4 and we hear a faster beating, la 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 la. That's telling us that the second partial is higher than the fourth partial and the octave is wide. What if we play the F3, A3, la 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 la, and the F3, A4 is slower, la 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 la? That tells us that the second partial of A4 is lower than the fourth partial of A3, and this is a narrow 4-2. Let's try the How to Tune Pianos online 4-2 hearing test. Here's the hearing test to tune A3, A4 as a pure 4-2 using the F3 check note. First we can play the octave. And what you want to listen for is the fact that there's a beating at the A5. Wow, wow. That means this is not a pure 4-2. Play the F3, A3, listen to its beat speed at A5. Play the F3, A4 and listen to its beat speed at A5. This is faster. This means that the A4 is higher, so this is a wide 4-2. The F3, A3 is slower than the F3, A4, so we want to raise the A3 so it will match the speed of F3, A4. Still too slow. Still too slow. Let's check. 15% narrow. The 10th is slower than the 3rd. Let's play and confirm. Oh yeah. So let's slow down the F3, A3. So the 10th is 3% slower than the 3rd, but the human ear cannot hear below 3%, so it sounds the same speed to our ear. Yes, and the octave is a pure 4-2. If you would like to take the test yourself, look for a link on this page and fill out the form, and you will get access to this free piano tuning hearing test. Good luck.